first question asks us about calculating the degrees of unsaturation. To do this, you have to know that for the unsaturations we look at rings, double bonds, and triple bonds. So rings count as 1 degree of unsaturation. So we have one ring, which counts for 1 degree of unsaturation, which gives us 1 degree of unsaturation from the ring. Double bonds each count as 1 degree of unsaturation. We have 2 double bonds times 1 degree of unsaturation each gives us 2 degrees of unsaturation. Finally, each triple bond counts as 2 degrees of unsaturation. So we have 1 triple bond times 2 degrees of unsaturation equals a total of 2 degrees unsaturation. We add these up and we get 5 degrees of unsaturation, and the answer is D. Okay, in question 2, it asks us to rank the alkenes in order of increasing stability. So what we have to do is look at the substitution pattern for the alkenes. And remember that as far as stability goes, a mono-substituted alkene is less stable than a di-substituted alkene, which is less stable than a tri-substituted alkene. And finally, the tetra-substituted alkenes are the most stable. So if we look at these, alkene A has 4 carbon groups attached. So that means it is tetra-substituted. Alkene B has 1 carbon group attached and 3 hydrogen attached. Okay, for substitution, we don't count the hydrogen. All we look at is this 1 carbon group attached, meaning it's mono-substituted. Alkene C has 3 carbon groups attached and 1 hydrogen. Since there's 3 carbon groups attached, it's tri-substituted. So based on this, our mono-substituted is least stable, followed by our tri-substituted, and finally our tetra-substituted alkene being most stable. So B, C, A, and the answer is C.